Hi guys, how you doing? Hope you're all well. So I've just bought this 80 quid, very fancy, very beautiful stepper motor from Amazon. Comes with this heavy, long stepper motor, plus this little controller. And, you know, I didn't really have a reason for buying it other than the fact that we have some at work and I wanted to learn how they worked. So I decided, you know what, I'll buy one and let's see if I can get a PLC to talk to it and tell it what to do. Now, originally when I bought this, which I bought it about probably 6 weeks ago now, I had this 1200 PLC, which is the DC-DC relay one, and I realized that you cannot drive a stepper motor using a relay output because that's just doing 24-0, 24-0, whilst using a DC-DC-DC one, which, don't ask me why, but I actually have two of them now. So I sold my 1214 that I had, that you've seen in other previous videos, and I've now got two 1212 DC-DC ones, and I still have this 1211, I believe, 1211, yeah, DC-DC relay. But this one I'm going to get rid of, so I'll just keep the two 1212s DC-DC-DC. So I had to buy one of these to make sure then I can control the stepper motor using the PLC, and I just want to display to you what I've got so far. So right now this stepper motor is disabled, so it's not enabled. If I turn it on, it'll go one direction using that switch, and then I can increase the speed up to a maximum speed, and then I can also decrease the speed. And I've got complete control of this on the PLC end, and then I could turn it off and then turn it the other way. And likewise, I can increase the speed. And it just works so well. And you know, it might seem trivial, but now that I understand how to set this up, how to wire this, all of this stepper motor controller in, you know, how to set up the technology object on the PLC end, I now feel like, you know what, any job with a stepper motor I could deal with, no problem. And what I've even done is that if you hit the E-stop, it will then disable the stepper motor. So you can see there, what actually happened was there is a disable is like a hard stop, turns it off, which is perhaps what you want if you have an E-stop. And the good thing is it doesn't kick straight back in there. So go to there, and then it'll go again. So what it is, if I let that ramp up, instead of disabling it by hitting the E-stop, if I actually just turn it off, you'll see it will gradually slow down. You see that? Versus, if I go back the other way, and then hit the E-stop, you get a dead. And it's incredible, man. I mean, stepper motors are it's brilliant, honestly. I love this, man. Just at 0 speed. And I mean, I haven't figured out yet how to do the whole homing and, you know, giving it a home position and stuff like that. And generally, I actually have no idea what I would drive this with. So, like, I mean, what would I even attach to the shaft of that? I've got no clue. But so you could probably hear that buzzing, right? So that's it, obviously spinning. Now, if I just turn it off, I don't know if you can still hear that, but it is still buzzing. But when I hit the E-stop, it just completely... So this is still enabled. I can't rotate this at all. But when I hit the E-stop, that buzzing completely stops. And then now I could rotate this. And what I've done is, which is quite clever, I've got it so that even like there it's enabled. When I turn it off, just my switch into the neutral position, it will stay enabled for 30 seconds. So right now, I can't turn that at all. But after 30 seconds, it will disable and then I'll be able to turn it again. So, which is actually a good feature that I'll probably need to put until the one that I've got at work, because the step motors I've got at work, they're just enabled all the time, constantly buzzing. So, yeah. All right, let me show you. Oh, this thing's heavy. I'll show you my PLC program. This program, super simple, is literally just, what is it, 4 networks. So in network 1, I've got, well, what I did was actually, first of all, I created this technology object, which was, you know, you go to a technology object, new object, and then motion control. And I think I did position and axis. So I've just got axis 1, and then I configured it. And I just told it, like, you know, okay, so my pulse output is Q0.0. So that's what I'm telling the stepper motor, and then direction as well, Q0.1. I haven't set up much of this stuff. So I've got pulses per revolution. I think I've got that off the back of the motor. And then, yeah, I didn't figure out really how to get homing set up. don't really fully understand that. And then so I use this commissioning tool to commission it, which was again mostly just jogging around messing it about. Then eventually I figured out in my main that on libraries over here I had a whole bunch of nope, not here. Where is it? Where's libraries? Instructions, sorry. Instructions, motion control, and then I had all of these motion control, power, reset, home. So I haven't played about with the home yet, although I would love to, where you basically give it a home position. So yeah, I think I'll get there with that stuff. But yeah, let me show you my program. What I've got is this is the power, so motion control power, which basically just you give it an enable signal. And so when I lose my e-stop, so my e-stop's always pressed, or sorry, my e-stop signal is always in when the e-stop's not pressed, right? So it's normally closed. When I lose that, so right now if I hit the e-stop, there I lose my e-stop signal, and then so that disables, that turns off the enable, so it's no longer enabled. And then down here I've also got, so this enable at the top is for my program. So if I tell it to do something, it will error out to say that it's enabled. But this output Q0.2 is actually wired into the enable on the not on the drive, what's it called? Yeah, on the drive, whatever it's, you know, the green square thing, the controller. Yeah. So this is actually wired into the controller, and this, when this output's on, it will actually turn off the motor completely. So that buzzing that you could hear when it's enabled, that's what turns it off. And then I've also got, if I'm not switched up or switched down, meaning, you know, I don't have a forward or reverse direction, so the switch is in my neutral position, and it's like that for 30 seconds, then it will disable the motor as well. So let me just reset my e-stop. And so if I put my switch now into forward, then now I've put it back into the neutral position. At the neutral position, I can still hear the stepper motor right now buzzing away. After 30 seconds, it will set that output stepper disable, which goes to the controller, and then that turns off the stepper motor. Then all I've got there is I've just got my push buttons, green and red, and I've just said on the positive trigger of them, so when you press it the first time, add 5,000 to the velocity. And I don't fully understand the velocity, but you can increment in increments of 1, literally. So you have very good speed control, and I'm guessing you could attach a PID controller to this. But what I found is that it won't really move much under 2000, really. Under 2000, yeah, under 2000 won't move much. But I've just said if it goes to a negative speed command, it just sits there, gets confused. If I give it a negative velocity, it doesn't work. So I've just said prevent someone from putting in a negative, anything below 0, then just set it to 5,000. And then I've also put prevent anyone from going above 70,000, because for whatever reason, I don't know why, but when you set the velocity above 70,000, it almost like it just halts. It's like the enable just crashes. I'm guessing obviously it has a max speed, or it could be a max current from a power supply. I'm not sure, but to fix that issue, I just said if you go above 69,999, then just move 70,000 into it. And so if I push that push button now, it's coming at 5,000. You can see there that I can make it go up and down. All right, and then finally I've just got my forward and backwards position, which is my switch. So when I switch up, it goes forward, and that's currently spinning one way. And then if I switch down, it goes backwards, and that goes the other way. And I mean, so this is a very, very, very simple bit of code, very simple, and it just works so well. And I'm flabbergasted at how well this code works. And so yeah, I mean, I look forward to using a stepper motor on an actual job, because usually these things are like attached to, you know, a spool on a valve, and then you're opening and closing a valve. So I'm guessing, you know, there's no reason why I wouldn't be able to stick a PID control onto this. I'm guessing maybe like a PID 3-step, and then actually control the speed of it like that. Yeah, I mean, at the moment I don't have an application for it. If you can think of an easy application, I did plan on actually going on and looking at 3D prints. So I was just wondering if I can print some shafts or something, like something that attaches to it. I don't know if this will exist. I want something that will go onto the shaft of the step motor, or like, you know, some sort of some teeth thing, something like that actually, like where I can move something back and forth. That would be cool. But yeah, I don't at the moment, I don't know. And to be honest with you, I'm quite happy with the outcome of this video. Just, you know, leaving it at that I now understand stepper motors. And so yeah, cool. If you got any ideas, leave them down below. And thanks for watching. Take care. Bye bye.